Let's take a look at arithmetic sequences. So we already know from the previous lesson that arithmetic sequence is a sequence in which a term is formed by adding a constant from one term to the next. So if I had the sequence of 7, 10, 13, 16, then to get one term to the next, every single time, I'm adding 3 to the previous term. I can always calculate that by taking any term and subtracting the term that came before it. For example, 10 minus 7 is 3. 13 minus 10 is 3. And 16 minus 13 is 3. We call that term or constant that we're adding every single time a common difference. And a common difference in our formulas is always represented with a lowercase d. The common difference in this example is 3. So one way to find a common difference is to take any term value and subtract the term that came directly before it. If I'm looking at example 1, if I'm finding the common difference here, I could take term 2 and subtract term 1, or I could take term 3 and subtract term 2, or I could take term 4 and subtract term 3. No matter which one I do, I always get the same answer of -3, which means that my common difference is going to be -3. For example 2, it says determine which sequences are arithmetic and find the common difference for those sequences which are arithmetic. So, for example A, I went from 2 to 4 to 6 to 8. The difference between 2 and 4 is 2. The difference between 4 and 6 is 2. The difference between 6 and 8 is 2. This is arithmetic. And the common difference is 2. For example B, the number decreased by 1/4, and then it decreased by 1/8, and then it decreased by 1/16. This is not arithmetic. For example C, going from -10 to -4, I increased by 6. From -4 to 2, I increased by 6. From 2 to 8, I increased by 6. This is arithmetic. And the common difference is 6 every single time. For example D, I went from 4 to 8 is 4, 8 to 16 is 8, 16 to 32 is 16. Once again, this is not arithmetic. Now, depending on the formula sheet or the example that you use, we always refer to the first term in an arithmetic sequence in all of our formulas by either T1 or the letter A. On our formula sheet, we use T1. Like I had previously stated, the common difference on our formula sheet is always going to be represented by D. That lowercase d helps you know on almost all of the formulas that it is arithmetic. So if you're looking at our formula sheet for sequences and series and you're trying to figure out which is arithmetic, anytime that it has a D, it has to be an arithmetic formula. So here where it says state the values of A and D, or in our case, T1 and D, in the following sequences, My first term that I'm given is -8. The common difference would be 2 minus -8, or 10. For the second example, the first term I'm given is 15, and the common difference would be term 2 minus term 1, or -5. Now, we need to be able to derive what the value of any term within a arithmetic sequence is going to be. So given this sequence, my first term is 2, my second term is 12, my third term is 22, my fourth term is 32, fifth term is 42. My first term's value, I started at 2, and the common difference is every single time I'm increasing by 10. So I could say that term 1 is 2, term 2 is 2 plus 1 times 10, term 3 is 2 plus 2 times 10, term 4 is 2 plus 3 times 10. Then I go 2 plus 4 times 10. Then I go 2 plus 29 times 10. And you can see that you're always adding 10 one less time than whatever the term number is. I don't add it for the first one where I start, but every subsequent one I add it that many times. Which means that how many times I add it here, it would be 2 plus whatever my term number is, because I don't know what n is here, minus 1 times 10. 1 less than whatever the term number is times 10. This obviously gave me 32. This gave me 42. And for this example, I could just plug into my calculator and discover that it's 292 without having to list out all 30 terms to get up there. Now, how does this work for our general formula? Well, term 1 was a, term 2 was a plus 1 times the common difference, term 3 was a plus 2 times the common difference, term 4 would be a plus 3 times the common difference, term 5 would be a plus 4 times the common difference. Obviously, term 30 would be a plus 29 times the common difference, or term n would be a plus n minus 1 times the common difference. And this is our basic formula that we use to solve it. Now, once again, we use the T1 version instead of A. But to find any term, I take whatever the value of the first term is, and I add to that the common difference times 1 less than whatever my term number is. So for this example, it wants us to determine the formula for the general term of the sequence. When it says formula for the general term, it means that I'm going to include the absolutes that never change. My absolutes that never change in my arithmetics are my first term, doesn't change, and my common difference has to be constant, so that also does not change. My first term here is -6. To get from my first term to my second term, I went up by +5. And then if my formula is Tn is equal to T1 plus n minus 1 times d. In this formula, my term value and my term number can constantly change, but my first term in any sequence and the common difference in any arithmetic sequence can never change. So those I can plug into my formula to state that Tn is equal to -6 plus n minus 1 times my common difference of 5. Now, sometimes you will see that they will try and simplify this formula. The simplified form of this would be if I took that n minus 1 times 5 and say -6 plus 5n minus 5, or Tn is equal to 5n minus 11. This form will help you solve any of the values in the function, and if it ever asks for the simplified form of it, this would be it. But typically, we just leave it in this form so that we can clearly see both what the common difference are and what the first term value is in our equation. If I am using this to determine the 12th term of a sequence, I'm going to say that term 12 is equal to -6 plus my n is 12 minus 1 times 5. I can plug all that in my calculator and get 49. I can also use this to find the number of terms in an arithmetic sequence by knowing what the first term is, the common difference is, and the value of the last term. In our previous example, we knew what term placement we wanted, which was 12, and then we were solving for t of 12, or the term value. In this case, we know the term value of our final number, but we don't know which term number it is, so we call this t of n is -117. It's still arithmetic, so I have a T1 of 3, and I have a common difference going from one term to the next of -4. I'm going to plug that information into my formula and say that Tn, which is -117, is equal to my first term, 3, plus n minus 1 times a common difference of -4. And in this case, I'm trying to solve that n value. So I'm just going to rearrange my formula. The first thing I would have to do is I'd have to subtract my first term from each side and say that -120 is equal to n minus 1 times -4. Second thing I'm going to do is I'm going to divide both sides by that -4. And I'm going to get 30 is equal to n minus 1. And then the last thing I would do is I would add 1 to both sides. 31 is equal to n. There are 31 terms in this sequence.